Hello students, in this session we are going to study the methods of finding the slope and deflection of a beam. What are the different methods of finding the slope and deflection? Basically there are many methods, but four are the most important methods which are in our syllabus for finding the slope and deflection. First method is Macaulay's method. Macaulay's method. This is also called double integration method. This is also called double integration method. As the name suggests, this is the double integration. We will do two times integration of our deflection equation to find the slope and deflection. So you know our deflection equation is given by EI d2y by dx square equal to minus m. This you already know, right? Or from here you can write that d2y by dx square is equal to minus m by EI, right? If we integrate this equation two times, you will get the deflection, right? So if we integrate once, then we will get dy by dx, that will be equal to minus m e by ei. Depending on the m, if m is variable, depending on x, then we have to differentiate it also. But if suppose m is constant, then we will get m ei by dx multiplied by x plus c, some constant c. So once we have integrated it, when we integrate d2y by dx, we will get dy by dx. The integration of this is, suppose this is constant, for the time being we are assuming that m is constant, then we will get this equation, right? And again we integrate it, then we will get the m which we want to find out, the deflection. This is the slope, this is deflection. This is basically slope, theta, dy by dx, tan theta, because theta is small, so we can write theta, and that will be equal to, if we again integrate it, this will be, suppose m and ei are constant, we are assuming that m and ei are constant for the time being, right? Later on we will do different questions also. So this is m by 2 ei x square, because the integration of x is s square by 2, right? Plus c1x plus some another constant c2. So by 2 times integrating, we will get the deflection. So this is the deflection equation. So this is the deflection of the beam, right? Of beam with constant bending moment. We are assuming that this part is constant here, right? So by this method we can find out the deflection, and integrating once we will get the slope. So once integrating, this is slope, and 2 times integrating, this is deflection. That's why it is called double integration method, right? So this is one of the method. Second method is that is moment area method. Moment area method. We will study in detail these methods, but I am giving a slight brief introduction of this. What is this method? Moment area method, right? So as you know that we have to take the moment of the area, right? So suppose there is a beam and it has a bending moment like this. Suppose there is a beam and it has some bending moment like this. Suppose randomly I am making, this is the bending moment, right? This is the bending moment of certain beam, right? And suppose this is the area. By taking the moment of this area, suppose this is a point of center of gravity of this point, about this point like this. Suppose this is the center of gravity and this is the distance of center of gravity of this area. So taking the moment of this area of the bending moment diagram, we can find out the deflection of the beam, right? By taking the moment of the area of this bending moment diagram. So we will study later on in detail how we can find out moment area method. Basically there will be two theorems, Mohr's theorems, for finding this. Mohr's first theorem and another is Mohr's second theorem. So we will use these two theorems. First we will define the theorem. What is Mohr's first theorem? What is Mohr's second theorem? And then we will take this is bending moment, this is the bending moment diagram of, and that taking and assuming that this bending moment diagram is an area, so taking the moment of this area about any axis will give the deflection at that axis, right? So that's why we are taking moment of area. And what is area? That is a bending moment diagram, right? So this is Moore's first theorem, and second theorem we will study later on, but this is another method for finding the deflection, right? One more method is the conjugate beam method. Conjugate beam method. Conjugate beam method. We will study later on what is conjugate beam method. In this also there are two theorems. Also again there are two theorems, Moore's first theorem and second theorem. In this also there are two theorems, Moore's first theorem, that is different from this theorem, right? And second is Moore's second theorem. Moore's second theorem, right? So what is conjugate beam? That is an imaginary beam loaded with bending moment diagram, right? Imaginary beam loaded with bending moment diagram. So what is conjugate beam? Basically we will study later on in detail. That is imaginary beam loaded with bending moment diagram. So first we will make the bending moment diagram of the beam, actual beam. Then this bending moment diagram, say it is a rectangle, suppose, right? So that beam will be loaded with that rectangle or variable load or a triangle, and that bending, when this is loaded with bending moment diagram, this beam is called conjugate beam. This is an imaginary beam, right? And two theorems will be used in this method, Moore's first theorem and second theorem, and then we will find out the deflection and slope using this conjugate beam method, right? We will study in detail. I'm just briefing this, that what are the methods, right? And fourth method is, that is strain energy method. Strain energy method. This is also important method, strain energy method. And another theorem will be used here, that is Cauchy-Lyanos theorem. Cauchy-Lyanos theorem we will study later on. We do not want to give the idea on this. We will study these methods separately. Each and every method we will study that. So there are four methods basically. One is Macaulay's method or double integration method. This is the deflection equation. This is the deflection equation. This, and integrating this deflection equation two times. That is why double integration, we will get the deflection of the beam, right? Another is moment area method. We will study two theorems in this, Moore's first theorem and second theorem, and we will find out the deflection and slope using this moment area method. Then there is the conjugate beam method. In conjugate beam method there are two theorems again, that is also the Moore's theorem, Moore's first theorem for conjugate beam method and Moore's second theorem for conjugate beam method, and we will find out the slope and deflection using these two theorems. And then there is strain energy method, that is also called Cauchy-Lyanos theorem. So using this Cauchy-Lyanos theorem we will find out the slope and deflection of the beam. So there are important methods for finding the slope and deflection of the beams.